These in class you were supposed to evaluate without a calculator. Log base 3 of 9 minus log base 5 of 1 over 125 plus, let's say, log base 1/2 of 4. So those are all things that you can do in your head without a calculator, just recognizing log to the base of answer equals exponent. And so you're thinking the base to what exponent would give that answer? Jonathan?
2.
Good. So 3 to the 2, because 3 to the 2 equals 9, because 3 to the 2 equals 9, the value of this is 2. And maybe we'll do a little side conversation here. How could we actually check to see that that is correct on our calculator? Yeah.
Would it be log of 3 divided by log of 9?
Close. So
9.
log of 9 divided by log of 3. So if you're sitting there with your calculator, you might want to try this. This is called a change of base. Okay, remember your calculator can do the common logarithm, log to base 10, natural logarithm, log to base e, or ln, natural log. So check that, and your calculator is going to say 2. So we're verifying that Jonathan is correct. Great. What about the next term? Log base 5 of 1/125th. Tyler. -3. Good. When you're doing these, you see fractions, think negative exponents. Because again, that's going to bring it down. You see fractions, think negative exponents. Do a little detective work. And this is -3. And so this is because 5 to the -3 equals 1 over 5 to the positive third, which is 1 over 125. Excellent. So don't forget that we are subtracting that, like so. And for our last term, log base 1/2 of 4. And so you're trying to figure out 1/2 to the what gives you 4. And again, you see fractions, think negative exponents. Yes?
-2.
Perfect. So take a look. We got 1/2 to the -2 equals 2 over 1 to the positive 2, which is 4. Great. So we just did that without using our calculator. We can check using our calculator, but 2 plus 3 minus 2 is 3. Okay, evaluate. This was the trickiest one for people in general. No problem. Okay, how about something that looks pretty simple? Solve. Two times 5 to the x minus 1 equals 7. There's something different about this equation, and that is that the variable is in the exponent. When you have the variable in the exponent, you know you're probably going to have to take the log of both sides. Great. And if we're doing that, should we use common logarithm or natural log?
LOG.
The LOG, the log. It doesn't really matter, but in general, students don't like natural log because they don't know what it means, so they use common logarithm. Okay, but first, divide both sides by 2. Okay? So get the base all by itself by dividing both sides by 2. And so we have 5 to the x minus 1 equals 7/2. Now we're ready to take the LOG of both sides. And so we have log of 5 to the x minus 1 equals log of 7/2. And again, either one, log base 10 or log base e will work. This is helpful to us because why?
Because then,
Megan?
because then you can move the x minus 1 down.
And it becomes a coefficient. Turns from an exponent into a coefficient, like so. Wonderful. Okay, so x minus 1 log of 5 and log of 7/2. And our last step, well actually, sorry, our second to last step, divide both sides by log of 5. So we get x minus 1 is log of 7/2 divided by log of 5. And our last step would be to add 1 to both sides. So I'm going to write that. Okay. So solve, evaluate, and there's one more thing. What was the other type of question that was frequently involved with this standard?
The ones where you multiply the two things like that. For example, log base 2 of 3x minus 2 plus log base 2 x plus 1 equals 1.
Well, that's like our first example where we're actually solving for x. There was another question where it asked some different instructions. Yeah, it's going to say express. Jonathan?
Like ln or e, those are confusing.
Those were confusing. Okay, so let's do one with natural log.
Yeah.
So here's what it's going to say. Something like express as single log, or express as a single logarithm. So we could have 2 ln of x minus 3 ln of y, and to make it kind of confusing, how about plus ln of e to the 5th? Alright, so what we're trying to do is take that expression involving 3 terms and condense it using the properties of logs. Using what Brianna just described, if you have an exponent, you can bring it down as a coefficient. You can do the reverse. You have a coefficient, you can bring it up as the exponent. We're also going to use this combining logs. When we have the same base, we can do that. You're subtracting, you're going to end up dividing what you're taking the log of. And then this, we can simplify. Ln of e to the 5th is 5. So they in essence cancel each other out. Right here, ln means this, log base e of e to the 5th. So if you think about this, log to the base of answer equals exponent. E to the what is e to the 5th? 5. E to the 5 is e to the 5th. Okay, so the value of this is 5. Oh, that's going to be a bad example though. Dang. Oh, well, we can edit that part out. All right. So, taking the coefficient. All right, moving it up. So maybe let's just, that was good practice with ln's, and let's erase that part. All right. So the 2 we bring up, and we have ln, not LO, ln, natural log of x squared minus natural log of y to the 3rd. You want to do that first before you add or subtract, multiply, divide. Lastly then, because we're subtracting the logs and we're writing that as a single logarithm, it would be ln of
x squared minus y cubed.
x squared divided by y cubed. Ln of x squared divided by y cubed. Okay, great. So let's